We're going to talk a bit about security, mobile security, and I honestly think that we have been looking in the wrong places, to be frank with you. You guys hear me okay? Is that all right? I think one of the key aspects about security is that there's no rule book, right? So the hackers, they don't run by a rule book. They don't run by a certain equation. They don't just always come through the front door, right? They figure out exactly where the weaknesses are, and they go attack that point. And so I think the topic that we're going to talk about today is very interesting because you really need to think like a hacker, right? So you look at where the pros and cons are, and you attack where you actually get the most yield, almost like optimization, almost like performance. So, and I think where mobile and IoT as well is different from traditional types of security is that you really cannot rely on almost anything. I mean, Google came out with the Trust No Network initiative, and I think they're exactly right in the money in a sense that I think that the key thing about security is you cannot afford to make major assumptions, right? Obviously, you cannot build on top of anything if you make no assumptions. You have to make some assumptions. But you have to understand that the penalty for making assumptions for too long and set it and cast it in stone, it's major. So you really need to, it's almost like I was describing to people, almost like how you treat your kids to some degree. I teach self-defense and martial arts as a hobbyist, and it's very much about making sure that whatever goes out the door, your kids going out the door, going to school, they understand what's needed, how to protect themselves, because you cannot lock them in the house. Very much like your mobile application. If you think that you can keep it under 100% control, you really don't know what environment the mobile application is going to be running under. So what you need to do is make the assumption that it's going to be running in a really bad environment. People can see what's going on. From that premise, you build on top of that your security aspect of it. So, So I have Lou with me today. So maybe just a quick intro. I'm Sam, CTO for Arcsan, and we'll talk a bit about Arcsan and what do we do. And I have Lou. Maybe Lou, you can introduce yourself.
Yes, Lou Crocker, Senior Solutions Architect working on the business development team at Arcsan, and it's my responsibility to own the technical relationship with Xamarin as we will talk about a couple solutions that we're working on to instrument some of the things we're going to instruct you about today.
By the way, we have a Q&A section. I want it to be interactive, but we do have a Q&A section at the end of it. So if you think of any questions, save it to the end of it. We also have a demo that we're going to show that Lou's going to help us with, and so I'll try to cut my part of it fairly short, but remember your questions and ask us at the end of it, please. So we're going to go through these items today. I'll skip through it. We'll just talk a bit about, so some of you might have read about this, but this is really how our company, it was very much about the premise of the company. So I don't want to go through all the detail about it, but some of you might know Shane Osborne and the situation where it was a Ares 2, it was a Lockheed plane that we actually lost years ago. And the DoD, after that situation, basically they looked at the situation and said, you know what, we want to make sure that any software that we have built, no matter whose hands got on it, no matter where it actually landed, no matter who have access to the actual software, we want to make sure that they cannot duplicate the software, they cannot take it apart and reuse pieces of it, and worse yet, they cannot actually reuse it and do worse things around it. We call it weaponization, which is injecting things into it and so on. And so Arcsan started out and really came out of that premise, if you will, which is make the assumption that your software could be running anywhere. It could be running under a virtualization layer, it could be running inside a jailbroken device, it could be running inside a device that could have IDC cable plugged into the network, into the hardware and all that stuff. At the end of the day, we want to make sure that we make it as difficult as possible for the attackers to decipher the code, to steal information, and worse yet, to code lift it, which is to break it apart and take out sections of it and reuse it. So, and I think the risk is really real, and I'll be careful. This is not about FUD. This is not about fear and so on. But I want to make sure that you understand that this is real. It's really happening. Now, I don't need to stand here and tell you that you guys are all here for the same reason. So this is preaching to the choir. That mobile is really exploding, and if you just look at the amount of transaction that's happening on mobile devices and the number of users on mobile devices, but if you look at retail, where a lot of transactions now are moving over to mobile shopping and e-commerce and so on, you understand that people's perception of I mean, my kids are always holding a phone. You know, my wife's always holding a phone. Everybody I looked at is always holding a phone. That's where their attention span is going towards. That's a lot of where their attention is going towards. And it's just exploding. And everybody wants some of that screen time. All the applications want to fight for that screen time. Everybody wants some of that. And as you go through and present more and more application, more feature to the mobile screens and the mobile applications, obviously there's more to gain from the attacker's perspective. And when there are things to be gained, obviously, right, that's exactly what the attacker is going to focus on more and spend more time on. And so this is, I believe this came from Eponym Research, you know, the top one. They're about, oh, this is Symantec, I'm sorry, right? This is actually about, on average, and this data is a little bit old. I'll be very surprised if it's not actually substantially higher right now. But it's 387 new threats every minute, right? Or more, you know, than every second. So it's basically substantially growing higher and higher. And the number of attacks that we're going to see is just going to go through the roof. And some of these attacks are manual. Some of these are through hackers. Some of them are automated. It's actually very sophisticated. I mean, we work with our customer. I cannot obviously disclose it in a specific way. It would not be right to do it. But at the same time, I could tell you that it's a real business for hackers to actually figure out how to get to the, you know, what you want to protect. And they're running it really, truly as a business in a sense that, you know, they would scale up and down on the virtual machines. If it's a brute force, they would scale up and down on the pattern recognitions on images where they actually use it for, like, you know, screening out numbers and credit card numbers, whatever it is. It's a real business, and you know, for them. And you have to understand this is how they think. So you can't just think that it's, well, it's a kid, you know, trying to hack it and trying to just be, you know, be famous about it. That's not the case anymore. There's always that. But you have to understand, it's really defending yourself. It's almost no different from how you actually treat your competitors to some degree. In a sense that, you know, as you defend your application, as you defend your IP, as you defend your data, as you defend your customers, you know, building a trust between you and your customer, you need to make sure that there's a counter side that could gain substantially from that as well. And the stakes are higher and higher. So we have some of the numbers here, and I strongly encourage you to go to our site. We publish all the survey and all the data we have collected. We never, ever disclose specifics, obviously, for real reason, because I always tell people, the good guys and the bad guys, guess what? We all use the same tools. So anything we disclose, unfortunately, would be used by anybody who could potentially do bad things about it. So we never disclose the specific. But at the same time, we want people to be aware that, you know, some of this data. For example, if you look, I don't know how clear you can actually see some of this, but if you look at each and every vertical, there are different aspects of it. For, you know, mobile payment, there is a much more higher drive around mobile payment for attacks on payment. There is, and most of the attacks that you see are things that's difficult to actually figure out. Meaning that if you actually see let's say it's a, you know, credit card theft, you won't find out until many, many months or even years afterwards. It becomes more and more difficult. So people don't just take your credit card and use it and then charge it big time. They skim it. Skim in the sense that they take $5 out of it, you know, $2 out of it, $5 out of it, and only until the very end when you discover it, they charge a big amount on top of it. So they're being very, very smart about how to make sure they stay under the radar and make the most profit out of it until it gets to a certain point. They realize that your lost cost, meaning that they can make more money out of you, then they charge you the extra amount, for example. And the same thing goes for, you know, other industry as well. So you have to understand, like I said, they're trying to make sure that they can run as long as possible. It's not about, oh, I'm going to hear about it in a 0 day and then I'll fix it. That's still going to be true for a lot of aspects of it, but that's not the only case anymore, right? So you see some of these risks that we're listing out here. So obviously a number of, you know, mobile apps, so the services, you know, attack services are increasing. So the factor is obviously increasing. The emerging IoT, I did a talk when I was in Vienna. I did an X-Tech talk, and I asked the audience, I said, you know, what do you think is the best debugging tool? I mean, hacking tool, I'm sorry. I gave away part of the answer, but what is the best hacking tool? So somebody said a debugger, somebody said, you know, a memory scraper. What do you guys think? What do you think is a great hacking tool? Huh? Telephone, yeah, very good for human aspect of it. It's very, very good, right? So anything else, email access to it for transaction, understand it, for social based on attack. Anybody else can think of a good, yeah? Huh? Yeah, sure, yeah, that's great, very good. Anyway, so yeah? Huh? I can't hear you. Yeah, sure, okay. That's, I think, and the answer I actually gave the audience was surprising. I said it's a milk crate. You know what a milk crate is? Just a little box you could stand on top of. And I counted how many devices were in the room. And I said we counted about 16 devices in the room. That was, access points and CCTVs. They were all, power over Ethernet based. And I said, imagine just standing on top of that milk crate, bringing it down, reflash it, bring it back up. How many of you guys actually joined a Wi-Fi and it said the certificate is not exactly clear, but you still click through it? All right? Chances are there was a man in the middle. I hate to tell, I'm not trying to scare you, but you do have to understand that it's so easy to access the path now to get between you and what you need to do, especially with the age of IoT, and it's only going to get worse. It's only going to get worse, right? So, faster release cycle. Obviously, the faster release cycle, it's great, of course. I love Agile. At the same time, it's also faster for attacker to actually find out about some of these aspects. I talked about it in a recent banking conference that a lot of people were going to OTP and on two-factor authentication and said that's the holy grail and that's it. Let everybody just go to it and solve all the problem. It's a great idea, but at the same time, it actually generates a lot of problem because SMS, redirecting, SMS, snooping becomes even more automated than the old way. So people don't even have to guess your maiden name anymore. They don't even have to guess your first middle school or grade school anymore. They could just actually attach to your SMS, snoop it, and then now the full loop is automated. So just be careful about at the same time, innovation is critical, but just don't make too many assumptions, as I said before. Use a third-party components and framework. You really don't know what's underneath it. You need to understand as much as you can underneath it, what's in it. But at the end of the day, you can't. I mean, you don't see the source, you don't know what they're trying to do, and you can't. You don't have time for it. The whole point of actually using the framework is so that you can actually use it and don't have to write it yourself. But at the same time, how do you protect it? That's why you need to clump it together, protect it around it, and all together. And then more and more increasing the functionality. So I was sitting down with the CTO. Actually, he was a friend of mine. And he was saying that Sam is okay. We don't put too much IP on the mobile part. And I said, that's great. But people don't use so much and try to steal your IP as much anymore. There was a big aspect of that. But the bigger problem is actually using your client against yourself, which is most of reverse engineering and hacking. It's actually done. If you looked at what happened with the Jeep situation, if you happened what happened with a lot of payment situations, what they're trying to do to attack the mobile client is almost like, basically, take the client, and from the service perspective, it's a valid client. It is their client, right? With the same key and same, whatever root key you put onto it, whatever it is, the API and calling, behavior and all that. They take the same client and they actually cut out the front end and put on top of it. Now to the server side, it's completely legitimate. It's your application. They use it against you, right? So in that case, you have a lot more to lose. In that case, they're basically using whatever you provide to actually get to your back-end data, get to your back-end services, to get to the rest of the service you have. So don't just think about, well, I have 5,000 lines of code on the client side, all right? That's what I'm dealing with. Don't worry about it. That's not the case. You have to think through the whole loop. It's the doorway to your back end. So look at that aspect of it as well. And then, on-prem and then, server-side software, right? So anything that you actually have, exposure, as I mentioned before, anything that you have exposure to running inside, untrusted environment, a lot of the technology we built on is what we call like black box-based technology. For example, encryption is great from one black box to another black box. Signing is awesome from one black box to another black box. When you go from one black box, opening up to a white box, the whole story goes out the door. All of a sudden, everything could happen, right? So you have to understand that. The phones, the devices out here, these are not black box anymore. Jailbroken devices, running inside a virtualized instance, running inside a container. I tap onto the hardware. It's not really black box anymore. I don't have to break into the data center to actually get access to it. All I need to do is jailbroke a device, download your application, and decipher it. And you see some of that from Lou today. Okay? And some of this, what I'm trying to say is because you're going to hear a lot about, we have a sandbox, perfectly safe, right? We're running inside an app store, it's perfectly safe. And you know that's not true. You know that's not true. And so, in fact, the reason why we've been in business for so long and, you know, for the last 15 years is because the key around a lot of what we do is about how we can actually make sure that we make it as difficult as possible for an attacker to decipher and get to what they wanted to get to. And it's to make sure that the effort they have to go through to get to what they want to get is not worth their time. It's never 100%, but it's about how you tune it so that you can get to a degree that you have the right functionality, right security, and at the same time, you can deter the attackers. So I'll go move a little quicker. I want to make sure you're leaving some time. So obviously, the industry is saying the same thing. You see some of this from the Gartner reports and so on, from the analysts. And this is a good chart that you would see that this is a Ponemon and an IBM research that on the right side, you see a spider chart. The red part, the risk, is what they looked at as a risk analysis, which is they're looking at, and I would debate that the human factor should be higher. I think there was a lot more on the human side that actually we're giving it credit for. So there was a lot of risk on the application level attack. If you look at the left side, over 84% of cyber attack now is happening in application layer. Doesn't mean that people are not doing port scan. Doesn't mean that people are not doing like SQL injections, all that kind of stuff. That's not what we're talking about. But where the highest risk, which is where people are actually gaining more maturity and being more sophisticated, it's around the application layer. Because from the logic to understand how the logic can actually break into it, it's much more difficult to track and to prevent. But look at the spend. The spend on the right side substantially is on perimeter, network-based, because that's the easy answer. I'm concerned about my data. What do? Put another firewall or, you know, enforce another firewall rule. That's true. You need to do that. You absolutely need to do that. But that's not where the fight is now. That's not where the fight for the last 10 years, honestly. But yet the easy answer is just dump more money into network security, perimeter-based security. And what I'm trying to tell you is that I think we need to redirect that, some of that intelligence, some of that spending, some of that investment over towards application layer. So here's a typical, you know, software security lifecycle. So you plan it well, you make sure you cover all the aspects of it. You know, you design, you build it, test it properly. You do your code review, you do your code scanning, you have your InfoSec team coming in, scan through it, you do your static analysis, your code analysis, you're making sure that, you know, you don't have buffer overruns and stuff like that. Great, good for you, wonderful. That's absolutely important. Sorry, hold on, did you go back? So then you deploy it, right? You run the application, you do your pen test before you deploy it. You make sure that whatever you're going to deploy it, you know, gone through it, and then you run it, and then you hope for the best. And then from then onwards, basically you have no idea what's happening to the application. So what's really happening, you know, obviously after that is, after you've gone through all those cycles, right, while you actually have the app in the App Store, while you have it in publish, wherever your publishing mechanism is, after you have that, people are attacking it. They put it in a sandbox, contain it as much as they can, they tore the connection, whatever they need to do to anonymize the connection. Now they start to attack it, run experiments with it. From then onwards, right, you're basically facing a number of people doing things that basically you can't defend against because the application has no defense mechanism whatsoever. So now it's up in the open. The guys could just, you know, do whatever they need to do with it. And in some cases, worst case scenario is, anybody heard of Xcode Ghost? Xcode, yeah? Worst case scenario is not only do they, you know, steal things, they take things apart, they actually corrupt your brand and corrupt your products too. We call it weaponization, which is they modify. So Xcode Ghost was a number of hackers basically, you know, modified Xcode, the development platform for iOS. They modify it themselves, and then they put it out in the cache server. A lot of developers actually used it, built application, and these are on some of the top 100 applications on App Store, build application, but the application at the tail end of it, because the tool was poisoned, the apps were poisoned. Went through App Store, got an App Store for months and months, if not years, got on it, and then when they actually download it, you know, to millions of users, and now you realize that you have a bad application. It was not the application provider's fault. It was not, you know, clearly not Apple's fault, but at the same time, it's up there. Why? Because you need to make sure that people cannot modify your application. There are things that could have been done to make sure that you protect the integrity, make it atomic for the application, for the ID in this case. So as I mentioned before, you know, you need to make sure you build it secure, right? So in the middle, you want to make sure you run your analysis and so on. but you really need to keep it secure, as we call it, which is making sure that the application itself has some built-in ways to mitigate against attack. And Lou's going to talk more about that, so I'll move forward a little bit. I think this is pretty clear, right? But I'll just run through it one more time. You know, unauthorized distribution, right? They want privacy. They want to steal the IP. They want to just ship it out. This, you actually see a lot of volunteer work type, like people just want to say, hey, I think everybody should have it, and then just, you know, crack it and then distribute it out and torrent or whatever it is. IP theft. They want to take away everything and reuse some of the code that you have. Sensitive information. They want to steal it. This is now doing some of the bad things, and you know, obviously there's monetary, there's revenue, you know, impact on all of these, but this is where you directly see some of the theft, you know, going forward. Bypassing security controls, anything that could be encryption, could be license, could be DRM, you know, and so on. And insertion of malware. That the last part is really where the weaponization comes in a sense that they would actually repackage the application, ship it out, and do really bad things out of it. So, I think, you know, so you see that these are the different impacts on each one of those. I think that I like that. That's actually very clear. But I want to skip to, so Lou, if you can give us a little bit about some of the tools. And again, these are all public tools. As I said, we don't disclose anything that's not, that's really sensitive. So these are all public tools. But the purpose of this slide, and for what Lou's going to show you, is I want to make sure that whatever we're doing here today are obviously being done by anybody could just do a Google, right? You Google for it, you do a search for it, you find this. So, but it's still good, I think, to actually show that how much of this, because there was a perception that people think that reverse engineer needs to be an expert in assembly or people who actually is hardware expert to do it. The fact is there are tons of tools out there that, you know, it's readily available by anybody. You don't need a pen tester to go through this. Pen tester, you know, obviously is given, but so maybe Lou, you can go through this a little bit for us. And
the key here actually that when I first saw this slide, the key to me is actually at the top there. Most of these tools are either free or very low cost. So the barrier to entry today for a hacker is very, very low. The most expensive tool on this list is IDA Pro at $1,100, but Hopper is $85, and you can actually get a free version that will work for 5 or 10 minutes at a time. We'll show you that today. It will do almost the same thing. So there is no need for a large investment for a hacker or any, you know, there's no barrier for them to attack your app once they get a hold of it. So everyone always asks us, isn't my app secure? We put it up on the App Store and Apple encrypts it, and then it gets downloaded to a device, and you know, it's secure. I believe in Apple. I believe that it's secure. Actually, not really. All that's required, and I have one here, is a jailbroken device, and to be able to download the app. And once I download the app, I simply, and the device is jailbroken, I simply have another computer here. This is basically a Linux computer when you get right down to it. And I can SSH into it. I can root around in the file system. There are tools that I can use to examine the applications. One of the key ones that we're going to be looking at today is Clutch. What Clutch does is it takes that encrypted app from the App Store and it starts the execution and immediately stops it right after the de-encryption, the encryption is removed, because it has to be unencrypted to run. Once it does that, it dumps it into, there are a number of things that it can do with it. It dumps it into an IPA. And once you have an IPA, you basically have the keys to the kingdom. Does anybody know what an IPA is? It's an application, but what is it at its root? It's a zip file. That's all it is. IPA is a zip file. You change the extension to zip. We'll show you how to do that. And you double-click on it. It opens up. You have everything right there for you. We're going to look at iOS. I always joke we're going to look at iOS because it's a little bit more difficult. Attacking an Android app is sort of like stealing candy from a baby, but that's really not, it's not fair to the baby because at least the baby puts up a fight, right? So we're going to look at iOS, and I'll show you this live. This is just a screenshot of what happens when you install Clutch, and you run some of the commands. It will give you a list of the apps on the device. You transfer those apps, once you dump it to an IPA, you transfer it to your laptop, your desktop, and you have full insight into what's in the app. So long story short, as long as your app can be downloaded or installed on a jailbroken device, there's no encryption. There's no security. You have to have, the application has to be able to defend itself by itself. So I know that most of you are aware of the structure of an IPA, but we're going to be looking at it as an unzip today. So I wanted to for if anybody hasn't ever seen this quite like this before, the binary, the resources, and the code signaturing and the profile, and sort of as a side, all the iTunes artwork, the icon, and things like that. The way that we actually, and I already alluded to this, the way that we actually attack an app is that we liberate the app. That means we download it to a jailbroken device. We then open it up, we check under the hood, we can run strings, we can run OTool, we can run any number of tools that developers actually use for the purpose of creating the app, we can use to disassemble the app. We can make changes to the application for many of the reasons that Sam was mentioning earlier, and then we profit or we cause havoc or we do any number of different things that is not intended for the original use of the application. So I'm going to escape out here just for just a second and switch over to my terminal here. As I said, I've got a jailbroken device. It's running 7.1, so it's a rather old device. And what I have here, oh, sorry, I've got to get them on my glasses so I can read it. I have basically that's my hacking device right there. I'm using iTunnel. If anybody hasn't used iTunnel, it's actually a fabulous little app that allows you to SSH over a USB port. I'm using iTunnel. What I'm basically doing is I'm creating the SSH port on a local port 2222. So once I hit enter, I've got a connection to my device. I then go down to my other terminal, and I SSH into the device. Now, big secret. Every iOS device that's ever been produced in the history of iOS devices has the same root password. Does anybody know what it is? Wow. You usually get at least one person who knows what it is. Nobody knows what it is. Every iOS device ever produced, the root password is Alpine. A-L-P-I-N-E. And what you can do, there's a story behind it.
It's public knowledge. So
it's public knowledge. We didn't give any secrets away. You can Google it. You can find it. So, I'm sorry, go ahead. Did you?
It's all in Google, I'm saying.
It's all in Google. So what I have now is I have a terminal into my iOS device. I can do normal commands like I could do on my laptop. I can CD back to the application level. I can see all of the directories on my iOS device. I've installed a tool called Clutch. Again, I mentioned it earlier. What it does is it loads the application, and then it stops the execution of the application right after the app is decrypted, and then it dumps the app to an IPA. So the command actually is clutch. Oops, if I could type here. -I. It will give me a list. Now, Clutch will only give you a list of apps downloaded from the App Store. There's other ways to get your other apps off, which we'll look at in just a second. And then the command would be, now I'm not going to do this, so nobody get nervous. The command would be to basically do clutch D on, for example, 1. Now, if I were to hit enter here, theoretically, it could take potentially 13.1 seconds to dump the Bank of America app to an IPA and all of its resources. Now, we're not going to do that because neither Sam nor I want to visit from Bank of America Legal. So what we're going to do is we are going to use an app that we have control over. I'm putting up this code sample. This is an app that all of you are familiar with in the Xamarin IDE. This is the Tasky app that I built earlier. And as I have a very old device, so there's no AirPlay here. But Tasky is running on this device. I can set it up, and I can run it right here. Xamarin, it says, and it will start up my Tasky app. And what I'm going to do here is I'm going to open up an app called iFunbox. If you're not familiar with it, this is also a free app. And what I'm able to do here is I'm able to then click on, and it knows my device is connected, obviously. And I'm able to click on the user applications. It'll give me a list of all the applications installed. I can go on Tasky, and if I double-click on Tasky, it breaks it open just like that. It's now open. Tasky.app is right here. If I can change the display to the list view, I now have the fourth file from the bottom. Tasky is actually the binary. what I'm going to do is I'm going to click on that binary, and I'm going to transfer it to my Mac. I'm going to put it on my desktop. And it will go through the process of transferring it to my desktop. I then have an app right here. Then what I can do is I can open up Hopper. And I have yet to even purchase this because I don't need to. And if I dump this in, it will ask me the architecture. I'll say, and it will actually it'll decrypt the app. It'll disassemble the app. Thank you very much. And what I can do is I have on the left-hand side, and we're not going to go through it. There's obviously a ton of things you can do. You can actually mess with the hex code. You can recompile it and reinsert it into the IPA and push it back up to a third-party app store. I'm just going to show you one thing. The reason why I had the actual code open is, as you can see, I have a couple functions here. I have save task. I have delete task. So if I go over here under labels and I want to see save task, and I hit enter, it actually brings up the code that was created during the compilation process for this application through the Xamarin compilation process. I can then click this button up here. I can get pseudocode. Now, generally, this is obviously getting into a little bit deeper into the bits and bytes. A lot of times, what people will use this for, at the end of this function, you'll see it returns something. It returns an object is what it returns. But in many of the applications, people will try and insert jailbreak detection, for example. And what hackers will do is they'll search for jailbreak in the function. They'll search for jailbreak in the strings, and then they'll just modify the return to return 0 or 1, whatever it is, to tell them that the app is not on a jailbroken device. Because oftentimes, certainly what we do is we have the app fail on a jailbroken device.
Or they would no-op it, or they would jump over it, jump into your routine right after authenticate. I mean,
right.
Typically, I don't know how many times you guys have a routine called, authenticate it, or, do check password or something like that. Right after that, of course, right after it's positive, instead of returning address, jump over what you need to do and jump back into it. Very, very typical cases. You don't need to know assembly to do that.
Yep. The other thing I wanted to show just quickly, which you've sort of already seen in pulling the app off the device, I also have Tasky here as an IPA because I wanted to be able to demonstrate this. If I take the IPA, you see it's got the iTunes symbol. If I change it to zip and hit enter, it's going to say, are you sure? Do you really want to change it to zip? I'm going to change it to zip, and then I'm going to unzip it, and I've got a directory. And if I unzip the directory, now within this, I don't have any certificates or anything in here. But if I did, they would be all listed down, certificates, all the artwork, even the assets, music, anything that's in there would be here. And the same way I could drag it across to the desktop and examine it would be this. It's exactly the same thing.
We see that all the time. Now, we only look at application that we have written permission for.
Yeah, that's very important.
We're on the ethical side, but we've seen this from working with our customer all the time, that the amount of information, even on the first layer of disclosure, I mean, we can actually see it very clearly. Certificate, as you were saying, right? It's
certificates and URLs are particularly valuable to hackers. One of the things that at the end of the day, what you have in your hand with this device here is really nothing more than an endpoint to a lot of applications. And so the same things that people try and attack endpoints, endpoint security is what you should think of this as in a lot of different ways. I think that's a good analogy, correct?
Yeah.
So now that you're all scared to death that your apps are wide open, or somewhere along those lines, what can you do about it? Well, we have, obviously we've been in business quite a while. We came out of the DoD space, but we moved into, with the proliferation of mobile devices and particularly gaming is a large segment for us, we really split off, and now we have our commercial sector. Xamarin is a huge partner of ours. We're very, very excited to be here today. We're very excited about the Xamarin platform. We're excited about the Microsoft acquisition. And we think that the Xamarin platform, as a mobile application development platform, cross-platform development, is going to do nothing but just skyrocket. So we are developing a couple solutions which we might be able to talk about if we have a little bit of time on ways to instrument your applications to protect in some of the ways I'm going to show here. Some best practices. I want to run out of time, so I'm going to show you. Sorry about that. I'm going the wrong direction. So code hardening, which we were talking about. and not just code hardening, but active code hardening. Take action upon detection. Don't let the hacker know what you're doing. And we have a case study we'll mention at the end. Add some variability. That's a big thing with our tools, is that the detection routines don't run every time through a routine, because if it does, a hacker can key off of that and then stop the application and avoid that routine. Execution probability is what we call it. And then you want to stay ahead of the hacker. You want to, as much as possible, release new versions. With our seeding technology, you get, in the old days, you used to have a binary that, for all intents and purposes, looked exactly the same from version to version to version. What we do with our seed technology when we compile the app is anything that you gain today is useless tomorrow with the next version of the application, and that's very, very critical.
Can I just tell you a quick true story about that? Different company I worked for, large company, and I remember there was one of the programmers very proud that basically he put a dialog box into the application that every time he sees, and he traps him by a now dereferencing, an odd address dereferencing. So every time he catch people who actually wanted to change the address back into an even to get around it, and he would display a pop-up box and say, "Got you," and he was very proud of that. And when I saw that, I laughed out loud, because I think basically what he just did is he basically shortened the path of what the hacker need to do by days, if not weeks. So never show your cards.
Yeah,
right?
if you attach a debugger to that application, you put a debug point right on that dialog box, you have the exact point where the detection algorithm was triggered. And at that point, you're defeated.
Pattern is the worst thing. It's like running any experiments. If they poke on one side, it always popped on the right side. That's a clear pattern. You don't want to have that. So you need to remove that, mitigate that, prevent that. But anyway.
What's key here in this slide, this is an overview of the way our technology works. Unlike many of the technologies that you may be familiar with, app wrapping, which is nothing wrong with app wrapping. There's a lot of great use cases for that. If you have control of the devices in an enterprise situation, mobile device management, mobile application management, they all have their use cases. As a matter of fact, many of those are our customers. Some of our customers are here in the expo hall today. But what we do is a little bit different. If you have an app that's wrapped, there's still a boundary. And what hackers look for, they look for the boundary. And so if you have a wrap that goes around an application, under static or dynamic analysis, you can find the boundary. And if you can find the boundary, under a hex attack, you can remove the protection. What we do with our insertion engine and our guard spec is we mesh the protection into the application, so there is no boundary. There's no way for a hacker to know where or what to remove. So we work not at the application level, but almost at a function level, where our guard spec can address function by function, class by class, what you want to happen. You have an authenticate method, as Sam mentioned. You want to protect that. You have a UI method. Who cares? They see the UI anyway. There's nothing secret about that. So it's sort of an art as to what you protect, how you protect it, and the level of protection you put against it.
That's a very good point. What you want to get down to, I use the term atomic. If you're an embedded engineer, it means something else, but at the same time, it's similar. That you want to make sure that your operations and what they want is atomic, in a sense that either they cannot run an operation, or if they run it, they cannot basically cannot take it apart, isolate it out, and then run just pieces of it. That's what you want to prevent, and that's what our product does, together with our active guards. So our active guards is continuously running as we actually protect the application, but at the same time, it makes sure that the whole application maintains integrity. Because once that integrity could be broken, then they have many different ways that they can actually start to attack it. Right?
As we're getting a little short on time, I'm going to go ahead and do this build out. So this is a crucial aspect of our technology. What you have at the bottom, labeled application, and in the lighter blue boxes would be your application. It represents the code that you would write, the functions that you would write, what you produce. The level 1 are the guards that a security engineer or the development engineer would create. This is where the function level aspects get addressed. You write a guard spec, you say, I want my authenticate routine to be protected, I want checksum over here, I want a swizzle detection, and then you write that, and that becomes the guard spec that you write. We then have a tool, L2P, which generates all the levels above that. Because what you really want to do is you want as many levels of indirection and protection as necessary. If you're going to attack, a fort and you shoot one sentry, if the other guy's looking at him, you're still not going to get through. So what happens if you come down and you try and take out the repair guard down here, you've got another repair guard looking at him, you've got a checksum looking at him, and you've got checksums above double checking. So the idea is that you want to vary what you do, and you want to put as many levels in as you can. Now, it's always a careful balance between protection, size, and performance, which is the delicate balance that we always work with. But within that, you come up with the perfect protection scheme for your particular application. The other thing that's critical is that at the upper levels, your reactions become a lot more subtle. For example, at the lower levels, you may just shut the app down. Of course, if you're running a nuclear power plant and you've got software that's being hacked, shutting down a nuclear power plant is not probably the best thing you could do. So there are other things you need to do. Degrade in subtle ways is a function that we use. There's different things. There was actually we're big in the gaming sector, and there was actually a game, I can't tell you which one, but if you were to acquire a vehicle without paying for it and drive around exotic locations while being chased by the police, they actually pen tested that game. And the pen testers got through, but they didn't realize that they had been detected. So the game, they were unable to win anything. They were unable to earn anything. And they never detected until they gave the report back to the gaming company. They never knew that they had been detected until they gave the report back to the gaming company. Many of our customers have, at the upper levels, a phone home. So that if the execution probability says the guard fires, they have a URL that fires home. They want to know who's attacking their apps, from where, and why. Just to finish up quickly, because we're almost out of time, the OWASP, which I know there was a talk this morning, Alec gave a talk this morning. This is the release candidate for 2016. What we do, the binary aspect, now what was M10 in 2014, it's now M8 and 9, split into two different parts. You can't even, I don't think you can read this, but it's the tampering and the reverse engineering. We also have, as a service from ArcSan, we have the free app assessment. It addresses more than this, and you get a full report, obviously with a signed NDA and all that. We don't hack your app without your permission, but you get a report as to where your vulnerabilities do exist.
As part of how we enhance our product and how we help our customer, we have a very strong red team that basically help our existing customer, but we also offer as a service with your written permission. Then we would work together with you to understand what the vulnerabilities are so that we can actually see how we can help you. Right.
And we just have, at the end, we just have a few use cases. The first ISV company, if anybody doesn't know who this is, I'm sure they would, can figure it out, but they have very expensive software. So they wanted to protect it because theft and off-license usage was a huge concern of theirs. Same for the company number 2, the largest CAD producer in the world. And the DRM customer, I'd be surprised if everybody in the room doesn't have this app on their phone. And they wanted to make sure that they protected all of their material. But now this is an easy one for us because it's mandated that any DRM has to be protected. So they've used us and they haven't been hacked since then. And of course, the gaming company I mentioned before at the bottom.
Actually, I made a challenge to an audience one time, and I said, I'll be very surprised if our software is not protecting some of the apps on your application, on your phone right now. And then one guy showed his phone. It was a flip phone running PPS. And I said, okay, you win.
So that's all the slides. We have, I know we're almost out of time. We have about a minute for Q&A, and certainly Sam and I will be willing to stand in the back if anybody has any questions, and we have a booth in the hall.
I think we have some questions here. So.
It was more common than anything, but with the open sourcing of Xamarin and everything else, one of the interesting attack vectors is obviously you've got open source code out there that as things are built on top of that, you're basically we're showing our hand sometime to cryptography and certain other things that we're using. So your solution looks really good for the binary side, modification of the binary, those types of things. Your services look good for how to protect against some of the other things that are out there. But what do you guys see as going into the future with open source libraries that are being used across everything?
It's a great question. I have my take on it. So you guys heard the question? So I'm a strong advocate for open source. At the same time, yeah. So I actually contribute to over 6 open source projects on my own free time. But I'll tell you one thing, that it really depends on what you're trying to mitigate against. If you're trying to mitigate against the professionals, open source is a wonderful thing. So basically, if you separate out the two, which is the script kiddies and the people who just download the script and run it, don't even understand it, that open source would actually make it worse. You have a lot more noise, but that's usually what I'm concerned about, because at the same time, you know, if you fall victim to those guys, I mean, sorry, I mean, it's really your fault. I'm just saying. But then for the professionals, what happens is, you know, if it's all out, as you said, all out in the open. For example, right, Heartbleed, OpenSSL, right? I mean, the string end copy is right there. The memory overflow is right there, right? People should have seen it. That was a failure from the whole, you know, open source, but it's still helping a lot. So I think it's actually a good thing for if you're handling the second part of it for open source, because now you're out in the open, more eyes are on it. Yes, they can attack, but as I said, good guys, bad guys, we'll always use the same tool. The perception that people can't see code, so the attacker can't get to, is actually not true. So for professional, they will get around it. So how we help is because we actually work with a final product, and what, you know, Lou showed you about the guard specs, about how to configure. The beauty of it is for us is, so we count attacked in weeks, months, and so on. It's never 100%. I don't think I'm breaking any news to anybody, but security is never 0, 100. It's never 100%. You never get 100% secure. I was talking to somebody yesterday and said, yeah, we achieve 100% security. I just fell off my chair. I was like, how did you do that? It's impossible. So, but false sense of security is a very dangerous thing. So open source, open it up. At the same time, how we solve it is by working on a binary level side and the configuration of guard spec. In fact, a lot of our customers use it that way, which is they understand, you know, what we call a range of attack, which is, you know, how wide is that number of weeks and so on. And they do an update. All you have to do with that, the configuration, you tweak it. All they have, and they will have to do it all over again, because just by changing the guards, you know, network, they have to attack all over again, because each one of the guards defend itself, and they help each other out. So the attacker basically said, well, I broke that, you know, checksum. I did a hook on that part. Now I got to do this part and hook into it. Now all you're going to do is release an update. You tweak it around. You're going to do it all over again. It's a great question about open source.
And literally, releasing the update is changing one number in the guard spec.
With no source code, so we don't see source
nothing
code.
else. You just change one number, and your final application looks completely differently.
But you always. I'm sorry. That's a different discussion. Yes. Can he get a mic? Is there a? Sorry. Go ahead. Obfuscate.
Does obfuscating your binary, for example, if you use managed code, you obfuscate your binary. Does that actually make a difference for?
It does. It does. It helps, but it's a very, very baseline aspect of things. It helps in a sense that you want to make it as difficult as you can, but at the same time, you do have to understand, as Lou was talking about, at some point in time, your obfuscation, I don't know how well you would do it, whether you flatten out your structures or your loops and, you know, you turn it into finite state machine, whatever you ended up doing, at the end of the day, there is a pattern to it, unless you actually do something very sophisticated, right? Which is, I mean, for example, like what we do far more than that, even on obfuscation, which is a baseline. But even if you do that, it still gets to a point that, okay, I know not one, but I know 15 entry points. I'll hook into all 15. So what? I'll still get to it. And then I tied it into whatever function they want to go to. It's still going to hurt you. So yes, do obfuscation. But you always juggle between 3 things. The level of security you're going to gain, performance overhead. There's always going to be performance overhead. And the footprint. Because you can compensate a lot of performance by expanding out, like flattening loops and stuff like that. But you're going to have to juggle all 3 of those things. That's the release engineer's and the programmer's job, to make sure that you balance out. You get 2 out of those 3, but never all 3. Okay. Anybody else? Any other questions? No? Well, thank you so much. Really appreciate you guys being here. So.